All right, guys, today we're going to be doing the notes of our quadratic attributes. I'm also writing on a different screen this time, so we'll see how that works, so bear with me. Normally this is a foldable where we only look at one little section at a time, but due to one note, we are going to look at all of them. So just, again, pause, back up if you need it. Each section is really, really critical. So the first thing we're going to look at is this left-hand section over here for quadratic graphs. And we're just going to touch a little bit of the information. And as we go through this whole note page, we will add to this graph. So the first thing I have is quadratic graphs. And on this one, the A value. So the A value is right here. This means the A value is greater than 0 because it's opening up. It is also positive. That means we're catching money. So Kyle's happy. He's catching all that money as it's falling down, and it opens up. So that's important to note. It opens up. It's a positive, and A is greater than 0, okay? On this one, it's going to be the opposite. A is less than 0, so it is going to be a negative. And it opens down. So he's sad because all his money is just falling to the ground. He isn't catching any of it. Okay? Our next section is the axis of symmetry. So we're going to talk about what the axis of symmetry is, and we're going to abbreviate it AOS because it just saves us a lot of time and effort. Okay, so on this graph right here, our axis of symmetry is just like a line of symmetry back in the good old days where you drew it straight down the line. So this is our axis of symmetry, and x equals -5. So it's where it crosses the x axis. So it is a vertical line, okay, at x equals -5. And x equals -5 is the equation of the line of the axis of symmetry. So it's a vertical line straight down it. So then when we look at the bottom, our axis of symmetry is the line straight down the middle, right here, and it would cross the x-axis at x equals -1. So this is the equation of the axis of symmetry. This is the AOS, and it is x equals -1. Our next one is our vertex. The vertex is on the axis of symmetry, okay? And it is where the graph changes direction. So it's where the graph changes direction. So it is this point right here, okay? So if you look at our graph on the left up there, where my point is, it is right here. That is the point where it changes direction. And you're just going to list what that vertex is. So I'm going to name it because this is some really important notes. We're going to have a major grade over this. Is -5, -8. So it is on this one, it would be the very bottom. So it is going to be the lowest point on the parabola. Okay, and it is going to be a minimum value because it is the minimum. Did I spell that right? That's weird. And it's -5, -8. The minimum is actually this -8 right here. It is the y value. So that is actually the minimum value of this graph. It is the lowest it goes. Then we're going to look at our bottom one down here, and you'll notice that on this one, the axis of symmetry is actually, the vertex is actually at the top. And the vertex on this one would be -1, 4, I believe. Let me double check. Yep, that is our vertex. So it is -1, 4. It is the highest point on the parabola. It is the highest. So the highest is the maximum. And the maximum value is right here. That's the highest it goes. So you're looking at the y value, okay? That is the maximum height, the highest it goes. Then we have our solutions, which we have covered extensively here. We have definitely been covering our solutions. And what else do we call solutions? We call them the x-intercepts, the zeros, and then the big one that everybody forgets, but it's always asked, is the roots. They are like where it goes into the ground. So if you look at the graph, the x-axis is your ground, and the solution is where it goes into it. So on this one, our solutions would be right here at -7. and at right here at -3. So I have -3 and -7. So my solutions are -7 and -3. They can also be written as points, which would be -7, 0 and -3, 0, because remember, a point is x comma y. And we've covered this extensively. So let's look at our bottom one. You might want to pause it and see if you can name it. Our roots are right here at x equals -3. It's ugly writing, sorry. And right here at x equals 1. So our solutions would be -3. Oh, and +1, excuse me. -3 and +1. To write them as points, that would be -3, 0 or 1, 0. The last one is the domain and range. Now, we haven't covered domain and range in a really long time, but as a reminder, and I'm going to do this in a different color so I can color code them for you. Let me find it. How about this blue right here? Domain is all your x values, and range is all your y values on the graph. So domain on these is super, super, super easy. Domain means how far to the left is this graph going to go and how far to the right. Well, this graph is going to go to the left forever. That just means it's a slow angle going forever. So negative forever is -infinity. Now to the right, it's going to go forever, and to the right is +infinity. So your domain is -infinity to +infinity. The other way this can be written is all real numbers, or the symbol, which we don't see in algebra all that often, so it really depends. And then the set notation is like this: x set of -infinity to +infinity. It's all of our x values, and you don't do equal to because you can never equal infinity. Now, this is always the domain on every quadratic you will ever have. This is the domain, and we're going to go back and look at the domain and range on our 5.10 notes at the end of this, okay? Now, that's always a domain. Now, let's look at the range. The range is all of your y values. So I'm going to remind myself and write a y right here. Forgot to put my x up there. Okay? Now, all of my y values for the range, all of the y values. So my lowest point is right here, and you go across, and that is at, that is at -8, I believe. Right there. It's not going to let me draw it, is it? Is right here at -8. So the range goes from -8 all the way up to infinity and beyond. You can't include infinity, but this is a bracket because you do include the -8. And this basically means y is greater than or equal to -8. Sorry, -infinity. That I'm getting myself a little bit confused right here, so I apologize. That would be -8. Okay? That's all you have to do for domain and range. So now let's look at our bottom one. Domain is the x value. Remember, it's always -infinity to +infinity. End of story. It's always this domain on quadratics. It's always going to go all the way to the left, and then again all the way to the right. The range is where you're going to change it up. So the highest value, this one has a highest value, is right here at 4. Sorry guys, at 4. So the range is going to be, let's see, the lowest value, because you go from smallest to largest, is going to be -infinity all the way up to 4. It includes the 4, but it's parentheses because you can't include the infinity. So basically y is going to be greater than or equal to 4. So the range, you're just looking at those y values. So let's go back. We've done all the information for this one. So we're going to go back to the 5.10 notes and do the domain and range on the other graphs. So I'm going to pull up the 5.10 notes that we previously did, and they're right here. And we're going to go down here and look at the domain and range as a review. Domain is always going to be, domain is all my x values, and it's always going to be -infinity to +infinity, which could also be written as -infinity, +infinity, including the x. Okay? Range. So on this one, it has a lowest point. If you look at this, your vertex is the lowest point at 4. So that means it's going to go from 4 to infinity, bracket, because it includes the 4, okay? And it also means that y is always going to be greater than or equal to 4. Domain on this one, I'm not even going to cover because domain is going to be negative infinity to positive infinity, always. Range is different. So here's my y values. It has a highest point at, well, this would be 0 actually. So y is going to go, the highest point is 0 and the lowest point is negative infinity. So negative infinity to 0. You can't include infinity and you do include the 0. So y is basically less than or equal to 0. Set notation would be a little bit different on this. Set notation would be negative infinity to 0 is your y value, and it would look like that, okay? So there's a quick review on domain and range. Let's go down here, and this one has lines for domain and range. On this one, the domain, again, negative infinity, to positive infinity. The range is going to be the lowest point is 3. So from 3 to infinity. You can't include infinity, but you do include the 3. So how that would look in set notation is less than and then equal to, like that. Domain, negative infinity to positive infinity. Range is going to be, a lowest point is 2. Okay, the lowest point is 2. So what I'm going to do for range is I'm going to go, it goes to positive infinity. So my lowest point is 2 to infinity. Okay, it's a bracket because you include the infinity. So 2 to infinity, your y value, less than, and that's going to be less than equal to. Now let's go back on these and let's look at our vertex. Okay, we've already done the solution, but I like to look at the vertex. And is it a maximum or is it a minimum? So I'm going to change to the vertex color. On here, the vertex is right here. This is our vertex, okay? And that is at 1, -4. And it is the lowest point, so it is a minimum. On this one right here, okay, it is the highest point, so it is a maximum. And our vertex actually happens to be our solution, which is 1, 0. This is our vertex, okay? Let's go down and do the other vertex. On this one, let's see. That vertex is, this one's pretty messed up. I did not do a very good job of that. This vertex is right here, which is at 2, 3. It is the lowest point, so it is a minimum. At this one, the vertex is right here. Which is at 0, -2. That is our vertex. And it is a minimum because it's the lowest point. Now what I'm going to go do is on the rest of these problems, I'm going to mark the axis of symmetry for y'all. I want y'all to see what the axis of symmetry is. That's the line down the middle. So on this one, our axis of symmetry would be this line down the middle, which is AOS, x equals 0. It's where it crosses the x-axis at 0. On this one, the axis of symmetry would be right down here at x equals 1. And I'm going to mark that AOS for your notes. On this one, again, your axis of symmetry is right here at x equals 1. So it's where it crosses that x-axis at. On C, your axis of symmetry would be this line right down the middle at x equals 3. And on D, your axis of symmetry, these are the easiest. Your line right down the middle, it would cross it at x equals -1. So we've reviewed all the concepts looking back at our 5.10 notes.